For each of these absolute value functions, I ask you to do three things. Sketch the graph, and then state the domain and range, and write a piecewise function. So here's what the graph of the first one should have looked like. What would you say the domain of that is? X such that X is an element of the set of real numbers. Yeah. So that means it keeps going forever to the left and right. Another way to write that domain, this is set notation, but we've also done interval notation. In interval notation, it would be negative infinity, comma, infinity in round brackets. But we'll use interval notation on the next one just so you see the differences. What's the range of this one? So if I'm going to write it in set notation, because we wrote the domain in set notation, what can we say about y?
Y is
greater than or equal to 0. Because it never goes below 0, right? The whole graph is above 0. So there's the domain and range. And like I said, that's set notation. We'll look at interval notation for the next one. If we were going to do interval notation, we'd say from 0 to infinity. And then the piecewise function is going to be y equals, and then we need the two pieces. So we have one function here, kind of that side of it. It's doing one thing, and then it switches and does something else. So if we look at the left side of that, we'll kind of split it right here, right? Because that's where it starts doing something different. So if we look to the left of that dotted line, what's the equation of that?
Negative x plus 3.
Negative x plus 3. Right, because it's crossing the y-axis at 3, right there. And it has a slope of negative 1, down 1 to the right 1. So negative x plus 3, and then you're going to say comma.
X is less or equal than 3.
Is that what you had, Leon? X is less than or equal to 3?
Yeah.
3, because you're looking at the x-axis here, and how far does that go? It goes right there to 3. So then we look at this other half, the right half of that. What's the equation for the right half?
X minus 3.
X minus 3. And that's x when x is greater than 3. Minus 3, because if we take that line and extend it, we'll see that it actually crosses at negative 3. But we have to extend it to see where that would happen. And then this is how I'm going to write it. Y equals, and then I'll do a big curly bracket and put the two pieces. The second one should have given you a graph that looks like this. Because it has that negative, right? And you're multiplying the absolute value by a negative, so it kind of flips it around. What would the domain of this be? Let's use interval notation for this one. So how far to the left does it go? All the way. Negative infinity. And how far to the right? Infinity. So that's another way to state the domain. Or you could have said the same as we did in the last one. X such that X is an element of the set of real numbers. What's the range for this one? So you need to look at what's the lower limit. How far down does it go? Negative infinity. And how far up does it go?
0. No, 1.
It goes up a little higher, right? To 1. But notice the round bracket, square bracket. Square bracket means that value is actually included, so it's like a less than or equal to. Round bracket means that value is not included. We never include infinity, we always use round brackets on infinity. The piecewise function, we're going to split it here. So if we look at the left side, slope up 2 over 1. So the slope is 2. 2x plus 1. That's when x is less than or equal to 0. And for the right side, negative 2x plus 1 when x is greater than 0. So that's the piecewise function for that one. This third one is an interesting looking graph. Domain. Negative infinity to infinity. Oops, that should have been a round bracket. Kind of halfway. And range. 0 to infinity. If I was going to do it in set notation, I would say domain is x such that x is an element of the set of real numbers, and the range is y such that y is greater than or equal to 0. So if you did it in set notation, that's what it would be. This is it in interval notation. Now the piecewise function, once you kind of see what's happening here, it's not too bad. And the way that you can see that is if you actually look at the original equation, y is equal to the absolute value of x squared minus 4. Well, if we just think about x squared minus 4, that's quadratic. That's going to make a parabola. So this graph is actually two parabolas. If I were to extend down here, you could see the outer parts are one parabola. So if we kind of go all the way down here, but all this negative stuff has gone into the positive because it's an absolute value. So when we do the piecewise function, this will be part of it, this dotted line. And the equation for that would be y equals x squared minus 4. It's a parabola that's moved down 4 units. So y equals x squared minus 4. And that's when x is less than or equal to 2, or x is greater than or equal, less than or equal to negative 2 or greater than or equal to 2. I think I'll put it down below so you can see that better. The second function that makes up part of this is this inside part, and if you wanted to see the whole function, that would kind of extend down like this. So it's this parabola, which is y equals, anybody figure that one out?
Yes.
Yeah, what is it?
I don't know.
So we have x squared minus 4. What's the other piece?
X squared plus 4.
Not just x squared plus 4, but negative x squared plus 4 because it's opening down.
Oh, yeah.
And that's if x is between negative 2 and 2. So we can write that as this. Negative 2 is less than or equal to x is less than or equal to 2. That means between negative 2 and 2.